Let's delve into the concept of growth. This question reads, the population of a certain country has grown at a rate proportional to the number of people in the country. At present, the country has 120 million inhabitants. 15 years ago, it had 115 million. Assuming that this trend continues, find an expression for the approximate number of people living in the country at any time t and the numerical difference. To solve this problem, we are going to analyze the first sentence mathematically. Now, if you read the first sentence, you have that the population of a certain country has grown at a rate proportional to the number of people in the country. We are going to have that our dp all over dt is proportional to p. Now, if you haven't watched our introductory video on applications of first order differential equations, I urge you to do so. Proportional sign, to remove it, you are going to apply your constant k and you include the equality sign. So this is going to yield dp all over dt equals to kp. dp over dt equals to kp. You can denote this as your equation 1. You can denote that as your equation 1. Now, what does p represent? What does k represent? Now, our p represents number of people in the country. Number of people in the country. Our k denotes constant of proportionality. Our k denotes constant of proportionality. And we have that our dp over dt represents the rate of population growth in the country. dp over dt represents the rate of population growth in the country. So you can recall from our equation 1, we had that our dp all over dt is equals to kp. So from here we have dp over dt equals to kp. This is going to yield dp over p equals to k dt. By taking integral of both sides, we are going to have taking integral of both sides. If we take integral of both sides, we will have integral of dp over p equals to integral of k dt. We are going to integrate this function, and that is going to give integral of dp over p, which is the same thing as by applying exponents to both sides. If I apply exponents to both sides, because I have ln, to take away the ln function, I need to apply exponents to both sides. I'm going to have exponent of ln p equals to exponent of kt plus c. Here, this and this can cancel. So from here we are going to have that P is equal to exponent kt times exponent c. E raised to the power of c is a constant. E raised to the power of c is a constant. E raised to the power of c is a constant. So since e raised to the power of c is a constant, it will be expressed as a. So therefore we are going to have that our p will now be equal to, in place of e raised to the power of c right here, we are going to denote that function with a. That will give us a e raised to the power of kt. Can call this our equation 2. A e raised to the power of kt. Going back to the second sentence of the question to get our boundary condition. Once you've reached this point, you need to get your boundary condition. And what was our boundary condition? We had, recall, at t equals to 0, that is starting from present, we had our p was equal to 120 million. 120 million. At t equals to 0, p equals 120 million. We will use this condition to find our a in equation 2. So we say that from our equation 2, we are going to have, in place of p, we are going to substitute 120 million. Recall that our equation 2 was p equals to a exponent kt. So in place of p, we are going to have 120 million. Million is times 10 to the power of 6 equals to a exponent k raised to the power of t at present is 0. 0 times anything is actually 0. So this is going to be 120 times 10 to the power of 6 equals to a exponent 0. The exponent of 0 is 1. So therefore, we are going to have that our a is equal to 120 times 10 to the power of 6. That is the value for a. So once we've been able to find our value for a, we'll proceed to find our k. This will help us to model our function and find any problem that we may be told to find. So to solve that, from our equation 2, we had p equals to 120 times 10 raised to the power of 6 exponent kt. Finding our constant means that we'll be able to model the question in any format that it may come up. So now that we've been able to find our value for a, we are going to substitute it into the equation and find the value for k. Once this is done, we'll be able to model the equation perfectly. So we have that our p will be equal to 120 times 10 to the power of 6 exponent kt. How do we get our k? To solve this, you need to go through the question again and pay close attention to the third sentence. So recall from the third sentence, we had that our t equals to minus 15. This is like saying 15 years ago. That means our p will be equal to 115 million. At t equals to minus 15, our p is 115 million. How do we solve for k? By substituting into our function above. So we are going to have that 115 times 10 to the power of 6 will be equal to 120 times 10 to the power of 6 exponent k minus 15. This is going to yield 115 times 10 to the power of 6 equals to 120 times 10 to the power of 6 exponent minus 15k. Dividing both sides by 120 times 10 to the power of 6 to make something subject of formula means to make it standing load. Exponent minus 15k would therefore be equal to 0.958. 0.958. Now, in this particular function, how do we eliminate exponents? By applying the ln function. By applying the ln function. Taking ln of both sides, we have minus 15k will be equal to minus 0.043. From here, we can make k subject of formula, which is equal to minus 0.043. To make something subject of formula means to make it stand alone. So from here, you are going to have 0.003. Therefore, our expression becomes p equals to 120 times 10 to the power of 6 exponent 0.003t. This is our expression. Whenever we are told to find an expression, this is how we model it. So in a nutshell, this is the expression for the approximate number of people living in the country at any time t. How do we find the population in the next 10 years? So we are going to solve for the population in the next 10 years. This means that t will be equal to 10. We are going to substitute the value of t into the expression. So recall, we had the expression p equals to 120 times 10 to the power of 6 exponent 0.003t. So by substituting the value of t, we will have that p is equal to 120 times 10 to the power of 6 exponent 0.003 times 10. If you multiply this, then you are going to have that your p of 10 is equal to, if you multiply this, you are going to have 123.655 times 10 to the power of 6. 123.655 times 10 to the power of 6. So you can recall our present population from the question. Present population is given to be 120 million. Present population is given to be 120 million. What happens in the next 10 years? In the next 10 years, we are going to have our P be equal to 123.655 million. Now, we are going to find the difference. The difference will be gotten by subtracting the two values, 123.655 20 million. This is going to give us 365,500. 365,500. Since the value is positive, we are going to say that therefore the population is increasing or it is growing. However, if the value was negative, we would have said that the population is decreasing. So that therefore the population is growing. In subsequent videos, we'll be dropping a lot of quizzes. Do well to subscribe to our channel.